Welcome. After this coffee break, we will start with the second session that's also about membrane technology in water treatment, and that will be chaired by Arie Haasnoot. And Arie Haasnoot works with Oasen in Dutch. That's the platinum sponsor of this conference. And may I ask the speakers also to keep a little bit here close to the microphone, because otherwise the technicians have some problems with getting the sound good. Okay, Arie Haasnoot, I give the floor to you.
Thank you, Jan-Peter. Thank you for inviting me here. My name is Arie Haasnoot. I work for almost 20 years at Oasen. Most of the time in the R&D department, last 5 years as a production manager. So that about me. About Oasen, Harry Timmer told you this morning about our connection with salt water treatment and membranes. So I will skip that part of my story. I would like to invite, as first speaker of this session, Mr. Marek Holba. He works at the Academy of Science of the Czech Republic. He was graduated in 2003 on wastewater treatment, and he will talk to us about the use of electrospun membranes, electrospun nanofibres for bacteria removal. Mr. Holba, may I invite you?
Okay, thank you for the introduction. My speech will be about the use of electrospun nanofibers for bacteria removal from wastewater treatment plant outlets. This research is part of the huge ground project of the Czech National Foundation that is solving the ASEO, like engineering company. I'm actually from ASEO, and another medium enterprise company is there, company called Spur, that owns the device that is able to produce the nanofibers by electrospinning. Then there are involved another companies, the Mendel University in Brno, Institute of Botany, Academy of Science of Czech Republic, and the last one is the Center of Organic Chemistry of Pardubice, which is responsible for synthesis of materials. What was the driving force for us to start such a kind of the research? Many countries all over the world is facing now water shortage and water environmental pollution, so that's why they try to find some solutions, which could be, for example, water reclamation and reuse from wastewater treatment plants outlets. However, usually the legislation or standards needs some pathogen removal. Pathogen removal is usually done by some UV or chlorination or ozone, but also another possible option is to use electrospun nanofibers. Here you can see the scan electron microscope picture from the electrospun nanofiber. For our research, we started to work with polyurethane nanofibers that are placed on the matrix from viscose. The average diameter of the nanofibers was 147 nanometers. Before the nanofibers were used, we sterilized them by UV for 4 hours. We decided to take the samples from the 3 different wastewater treatment plants that have also very different technology. The wastewater treatment plants for 500,000 population equivalent has to fulfill very strict outlet limits, which are like 1 milligram per liter of total phosphorus, 12 milligram per liter total nitrogen, and 45 milligram per liter of COD. Then we chosen the wastewater treatment plants for 8,000 population equivalent that has to fulfill not so stringent limits, about 3 milligram per liter phosphorus and 25 milligram per liters of total nitrogen. And we also chosen some very small wastewater treatment plant which has not so stringent outlet limits. It has only the suspended solids, about 70 milligram per liters, and COD about 150 milligrams per liter. Also, of course, there are different technologies used, and also there was expected very different amount of the bacteria in the outlets. This is our testing device which we used for our tests. That is the way how we perform the test. We took 100 milliliters of the grabbed sample, and we placed into the device. We made pressure of 1 bar, and we filtered the sample, and we measured the concentration of microorganisms after filtration. Here is placed the nanofiber. The device was always sterilized before every measurement. We decided to compare our results with national legislation about water reuse or reuse of the water from the outlets of the wastewater treatment plants, which is possible by Czech national legislation. There are several standards, and most of the standards is focused on those kind of microorganisms, cultural microorganisms at 22 degrees and 37 degrees, then thermotolerant bacteria, then Escherichia coli, and intestinal enterococci. We always calculate it like CFU in milliliters and triplicate every measurement. Here are the results of our experiments. That's average from several measurements. As you can see, it's visible that the plant number C, which is designed only for 150 population equivalents and doesn't have so big treatment, so advanced treatment, so there is so many microorganisms. And as you will see also in other slides, it doesn't fulfill most of the national regulation on standards for water reuse. At first, we started to compare with government direction number 23 from this year, which is about microbiological quality of treated wastewater with reuse potential. There are 3 possibilities about reuse: for water supply, for swimming purposes, and then we have some new things in the legislation. It's environmental quality standards. As you can see, the plant number A for 500,000 inhabitants and plant number B for 8,000 population equivalent were mostly able to fulfill those paragraphs of this direction. However, plant C never was able to fulfill any standard. Another government direction which we are trying to compare to is the government direction for potable water quality and hot water quality. There are also mentioned other microorganisms in this direction, but we did only those 5 because it was for most of our tests necessary. So as you can see, for potable water quality, none of the it was impossible to achieve the values which can be lower than threshold value, and also for hot water quality. The last national standard which we were comparing to is the Czech standard for legislation for irrigation. We tried to compare which if it can be used for unrestricted irrigation, restricted irrigation, or not proper for irrigation. As you can see, for unrestricted irrigation could be used after application of nanofibers only the effluent from wastewater treatment plant A, and for restricted irrigation could be used the wastewater treatment effluent from plant B, and from plant C couldn't be used for irrigation. There are some sim analysis of from the nanofibers when we make the wastewater filtration experiments with wastewater. You can see there probably some diatoms. There will be some pollen seed or something like that. Something we don't know what it could be. The main conclusion, we started this research this year, so we just are trying to find the application of nanofibers in the environmental protection. We are trying to do air treatment. This is the second thing which we are trying to do is trying to apply for wastewater treatment, plant outlet filtration for other kind of the reuse, and we can decrease the amount of the bacteria in the treatment plant outlets by log 2 or log 3. However, it's not sufficient enough. If I remember, just if we use ultrafiltration membranes as the way of the treatment at the treatment plants, we can achieve the log removal about 3 to 5. Also, the results did not show high efficiency of the pathogen removal. Some reuse scenarios could be applied, for especially in the case of the huge wastewater treatment plant, which has also some kind of the advanced treatment. Now we start to focus to find some proper material which will be able to remove more pathogens, and we try to functionalize the membranes. And also another step will be also to do some long tests, which will take a long time. It will be not only like the batch test. Thank you very much for your attention.
Thank you very much, Marek.